Listo ya. Ya estás transmitiendo. Sí, ya estás transmitiendo. Ya está. No, vale, ya lo subí. Yo sé.
Vamos a continuar si gustan tomar sus lugares.
Okay, we ready? Yeah. So, talk about the outdoor unit. Tank weights, vertical components, the outdoor unit components, installation, business operation, the outdoor. So the first thing we have, obviously, is the compressor, part of the system, makes everything go around. This is a three-phase compressor. It's also specifically designed to operate with this unit. Paired with a variable speed unit with vertical pumps. Okay? So it's a specific type of compressor for that. We also have a suction accumulator. It's liquid refrigerant compressor. And something that can result in returning compressor, such as compressor slowing faster than the refrigerant, or overcharging, or low airflow. Those things can make it leak back to the compressor. This is not a receiver, this is an accumulator. We also use a swept fan blade, a swept design fan blade, because it optimizes airflow and system performance. Okay? VSODU is a variable speed outdoor unit controller. Again, like we said at the beginning, it is the brains of the operation. It processes various inputs that come from the pressure transducers, comes from the temperature sensors, it comes from the other boards and the Unidad thermostats. All of that is communicated. By getting all those inputs, it determines our system operation. Okay. Now, this is what the board looks like, and this is kind of giving you an idea of where everything connects. So if you're looking at the board, we'll start at the top right here. This is your outdoor air temperature sensor, which that is located underneath the electrical panel on the outdoor unit. You have your coil temperature sensor connection. This is which is connected to your outdoor coil. You have your suction line temperature sensor connection, which connects to the suction line and it reports back. This is your model data card right here. If you change this board, you have to make sure that you pull that model data card off the old board, put it back on the new board. If you do not do that, the system will not operate. Okay, it's imperative. They even have that card tethered to the outdoor unit, so when you take it off, you have to remove it. And it just dangles there, so you remember to put it back. We have a liquid line temperature sensor connection, fan motor speed control, suction pressure transducer, liquid line pressure transducer. This is your EEV connection where your thermostat or your expansion valve connects. Reversible valve connections are here and here. These are your EXV status lights. Remember, those are the ones that green is blinking, it's opening. And on the outdoor unit, it's not amber, it's red. Rojo blinks when closing. Okay? You got your dip switches, which remember, if we have the Econet control, you have no need to touch. LED power lets you know the system is powered up. You've got a 3-amp fuse for protection on the board. Then your thermostat connections here. And also your E1, E2. Okay? And you've got your Ethernet communication LEDs. Right? That lets you know the system is communicating, blinking on and off. Okay? Variable speed outdoor control board manages the functions of the outdoor unit and handles the communication between the outdoor unit and its smart thermostat. Okay? That's its job. On the drive board, a few things to know. Remember, I told you that your filter board powers in here, so if you're checking power incoming and you check it at the filter board and you go through on that filter board, when you get to here, all of those voltages should be the same. Okay? You also have the choke that we talked about that is monitoring electrical spikes, that actually absorbs those spikes. This is where that plugs into the board. Okay? You also have what we call the Modbus BSODC connection cable. It's a communication cable that runs from here, goes back around and ties into the BSODU. So one of the codes that you could get would be a communication fault on the outdoor unit. If you get that fault, that's the first thing you want to check is that Modbus cable, right? You want to check that cable going from the BSODU back to the drive board, because if it's not connected properly or a wire is broken, it will throw a code and not allow the unit to operate. The other problems that it can be would be either the drive board or the filter board, not the filter board, I'm sorry, the BSODU. But most likely it's that cable. Okay? You have the indicator LEDs that link here to let you know what's going on. This is where your compressor discharge temperature sensor button looks at. High pressure switch connection. Then your compressor output voltage to the square go to the compressor compressor. Okay. So the discharge line thermistor, the discharge line thermistor sees 225 degrees. Is that Celsius? A lot of
100. 100. 5. Ah, 105 grados Celsius.
$107.2.
No, 107.
So discharge line sees 225 more than 30 seconds is going to give you a fault code. Compressor RPM is reduced, we call it cold patch. Reduce the RPM and try to cool the compressor down until the compressor gets below 200 degrees Fahrenheit. Once it gets below there, it will allow the compressor to ramp back up. But if it does not cool off, it will shut the system down and throw another code that the compressor can cause. High pressure switch connects directly into the voltage, to the inverter drive board. It is auto resetting. It opens at 610 psi and closes at 490 psi. Okay. Then you have an outdoor air thermistor on the system. That outdoor air thermistor just senses temperature of the outdoor air. The air that's going across the floor. Okay. You can't see it because it's behind the marker. But I'll show it to you when we get there. Now this is a breakdown of how we convert AC power to three-phase DC power. Okay? I'm going to try to make this as technical as possible without confusion, if I can. So when you have incoming power, 220, 208, 230 volts, right, coming in, that voltage is brought into the board. Now in section 1, what we do is we supply the voltage up to fill up the capacitors up there. But how do we do that? We first have to convert that to DC power. So does anyone know how to convert AC to DC? What is used to make that happen? Diodes. Diodes. Capacitors are just storage, right? Diodes are what change how power is seen, right? So AC alternating above and below the sign line, right? So DC straight. So when we run the AC power through diodes, it converts it to DC power. It stores that DC power into the capacitors. Now, it stores the voltage from 1 to 1 and reads section 4 with voltage from the terminals DC plus and DC minus. Now, if you want to know if we have DC power stored in those capacitors, you can test the DC plus, DC minus, and you should be reading about 4 times the incoming voltage. Okay? So 220, you should be reading 300 and something volts, right? Or something like that. So you should be reading 4 times, right? Or, I'm sorry, 1.4 times, not 4 times, 1.4 times. So a little over 300 volts, right? 360, 380, depending on what the voltage is, it will vary based on your incoming voltage, but it will be somewhere roughly around 1.4 volts DC coming in.
Well,
Okay?
when you convert from AC to DC, the diode, you also generate some noise, right? You take it off with some reactor or.
There's not really a lot of, we don't generate much noise in these systems. So you're talking about the feedback coming back?
No,
Just for,
but every time you change from AC to DC, I understand the diodes, but they keep the currents almost straight, but there's some noise generated.
there is, and there's, within this board, there's built in that will pick that up and take care of it, I'm sure. I don't know what they use in that board to do that. But I know that you don't hear any noise when that's happening, right? There's no noise that you're picking up or any feedback. Not that I'm aware of, I haven't seen it. Open your head up for back there.
Sometimes some of it, some units, they take out whether the positive cable or the negative goes to a reactor and then comes back. That's what I thought I saw when you were talking about the choke line.
No, that choke, it brings it back. It actually, one line beats up, it does come back, so it takes out spikes. Right? Any kind of spike voltage is what that's.
It's still.
Yes, still needs it. But it's still, it's not taking care of noise, right? That's right. Okay. Did you get that?
Not the last part.
So what you're saying is, with that choke, it just turns the excess voltage. Now you can over voltage and power capacitors. So that's got to be changed to something else. Right. Right. So it goes to the choke.
And it is on the DC side.
Yes, it is on the DC side, but it's not dealing with noise, right? That's not what its job is to do. Nothing there is to deal with noise when we're converting AC to DC, right? That's on the DC side as well as on the AC side. But like he was saying, revs down or you're overcharging those capacitors, that's going to turn that into an energy, right? It's going to remove that off so that you don't damage the store. All right, so once you get that, we're moving over to section 3. DC voltage capacitors, it converts it back to AC. How do we do that? How do we convert back to AC? Anybody know? You know? I don't know. So when you change AC voltage, you have to convert it to DC. When you change it to DC voltage, you have to convert it back to a sense. So that it knows it's a 3-phase AC compressor. So it has to have simulated AC sine wave. So how do we achieve that goal?
Power module?
It's called an IGBT, integrated bipolar transistor. Okay. So what that does, right? It has a series of switches inside. Those switches, there's 6 switches. So those switches will open and close at different intervals, at different speeds. Okay, so as those switches are opening and closing, one opens, one closes, that shows the sine wave back right. Starting to show you a sine wave out, flip the flops back over the sine wave or the sine line. So as one switch opens, goes below, the other switch opens, goes above. You've got 3 switches, which are 3 phases of power coming back. So our 6 switches over the 3 sections of switches will flip back and forth.
Can I draw the system?
Did you
Can I draw in the?
draw?
this understand.
Yeah.
The table.
Yeah. Absolutely.
Max.
You would have-
Bueno, acá estaba explicando un poquito de cómo hacemos la conversión de 40 Después vamos, nos regresamos a la parte de economía alterna para la parte de motor. Entonces, en la tarjeta, nosotros se dan cuenta, ustedes van a encontrar la conversión. Antes son las conversaciones. A ver cómo lo logramos a través de una conversión de GDT, que estamos en los tránsitos, que normalmente estas son las señales, ahorita tengo. Pues aquí manda una señal, aquí vamos a tener, vamos a pasar por el positiva y acá vamos a pasar por el negativo. Entonces cuando activamos uno, este se apaga y aquí vamos a lograr. Normalmente no vamos a rectificar estas señales centrales, cuando rectificamos al inicio. Cuando rectificamos el inicio, pasamos por el alterno, pasamos a nuestra corriente directa. Pero antes de rectificar, tenemos ruido. Ese ruido es este. Nos rectificamos con el banco de registros, con los colores. Este nos ayuda para identificar el ruido. Este, 295 a 335. Este voltaje lo vamos a mandar a nuestra tarjeta y aquí vamos a hacer esta transición. Lo pagamos y prendemos y aquí vamos a lograr esto. Pero lo vamos a lograr pisos, corriente de pisos. Pero nuestros compresores como si fueran básicos. Por eso necesitamos 6 arreglos de este tipo. Serían 6 transistores para poder hacer la inversión. Y esto va en secuencia. ¿No? ¿Para qué? Para lograr un arreglo básico, nosotros mandamos una señal secundaria básica. Luego, a esta altura, mandamos la secuencia y luego a los 270 mandamos la secuencia. Y es cuando no debemos escuchar. Esta frecuencia la aumentamos a la reducción, es como vamos a ir aumentando la reducción. No, porque aquí, a través de cómo mandamos las señales, tenemos que estar en este video, vamos a quitar uno u otro de los señales. Entonces, de más rápida sea la frecuencia, más velocidad de radio, y entre menos sea la secuencia que mandamos, menos frecuencia.
La salida. ¿La salida?
¿Cuál salida?
De los.
La salida.
What is the difference of the output of the compressor?
They're very right. So various.
What is the range from 100 to
It's hard to say. I've seen it today. You've seen voltages from ranging from what going to coming out of the BMW. I've seen them anywhere
It
from.
depends on the computer you use. So if you have a meter with this certain part of this,
Yes.
that or not, you're gonna get somewhere down at the bottom of that white box. It's gonna be somewhere around 277 volts AC.
Yeah, I've seen it. And it can also vary based on incoming power. You've got lower income power, high income power. So it depends on what your power is, but it's going to be a ratio. I mean, I've seen it in Florida.
If you don't have a true RMS meter,
so you need the proper meters. But I've seen it as low as 245, 250. And I've seen it as high as 370, 380.
Yo lo entiendo los compresores que los mandaste a la mitad
Ok.
y arrancan el voltaje del motor, ¿no? Que te van hasta el modo forzado hasta 60 volts.
60 volts.
Sí. Y no se permanecen en 20, 22.
Lo dices muy lento.
Ahí está el
No, 60, la cuestión de revisar. Normalmente es porque el mismo el compresor te marca, tú ves el rango del compresor, muchas veces de 100 volts hasta 80, que más o menos es el rango de operación del compresor, dependiendo la frecuencia, más voltaje y versa normalmente. A frecuencia te maneja menor voltaje. Está raro eso, porque si no, digo, normalmente debería de ser, ahora sí que algo parecido a lo que manejamos estándar, ¿no? De 220 Hz. En base a, digo, si incrementas la frecuencia, entonces ya te debería de bajar el voltaje y te iguala, incrementa el voltaje y la corriente, ¿no? Y se ve. Ahí sí pudo haber sido bajar. Sería cuestión de checar. Pero la mejor manera sería con un osciloscopio, la verdad, ¿no? Para ver la frecuencia y el voltaje. No lo mide exacto. Yo le voy más a eso. Un osciloscopio. Las tres fases. Sí, de hecho hasta ahí. No, y de hecho, con respecto a lo de los diagnósticos de los compresores y los inverter, hay dispositivos que son parecidos a los diferenciadores de fase. Entonces tú lo conectas en un...
Yeah, I do the same thing. So we wanna talk about how to see if the compresor is damaged. So if there's output voltage on the boards, one like David was just talking about, right? If all of your legs, when you measure ohms on the legs, all three legs, are they close to the same or at the same? The compressor's okay. If you own all legs to ground, there's no ohms to ground, right? Compressor's okay. If the board is sending voltage, that's the board. Sometimes compressor though can be locked up and it's sending voltage to the board or to the compressor. But if the compressor is liquid locked, there is a procedure that you can do to try to get that to go away. One of the things you can do is pull some refrigerant out. See if you can get it to start. Another thing you can do is put a belly band crankcase heater on the compressor. And if you start to see ice up and start to see that refrigerant boiling out of the oil, then most likely it was locked up. And once that's gone and that dissipates, it can start again. There's also times where the compressor is just locked up and it won't move. Check, right? David was talking about checking amperage on all legs. That motor's locked up, there's going to be a higher amperage because it's not turning. It's trying, it's not. So there's several ways you can determine whether or not it is the board or the compressor. Typically, what I tell people when they are troubleshooting boards is power in, power out. Power into the board and power out of the board. The board is it's something else. So look for something else. There's a percentage of boards that we get back from people saying that they were defective. We find no fault. Very high percentage. So a lot of times, especially in our country, US, they change the board first just to see if that works. That's not the proper way to troubleshoot the system. It's use your meter. You can find out if you have incoming power and outgoing power, leave the board alone. It's not your board. I have people that will call me and they say, I've changed the board 3 times and it's still doing the same thing. And I say to them, all you've told me is it's not the board. Stop changing the board, right? Find your problem. So some people in the US are lazy. That's all I can say. They don't want to work. They just want you to tell them how to fix it, right?
It makes it the same.
It's the same.
It's the same, yes.
Yes. If you're going to be checking, if you're going to be holding out the compressor, doing all that, yes, you want to disconnect the system, turn the power off, and then check it. Also, anytime you turn power off on this system, give it at least 5 minutes before you start putting your hands in the system, because these capacitors can kill you. Okay, these capacitors have enough power that they can go straight to your heart and shut you down. So give it time to dissipate, make sure all lights are off the board, then you start troubleshooting, okay? How many of you have ever been electrocuted by just sticking your hand in the panel and something grabbing? Anybody? Everybody, right? It's happened once or twice. You don't want that when that's power up. So don't stick your hands in until all the lights are gone, okay?
Now, sometimes it's taking out voltage, maybe the sequence is not correct, the compressor is not going to take it. That's when their inverter check.
We don't have an inverter. All we have is a meter, 2 RMS meter. I don't know an inverter check kit as far as our systems, right? Like most VRF that I've worked on, there's a computer. I will plug it in. It'll come back. This thing, sure it was.
It's a generic tool that works with any compressor.
It probably just.
It does, yeah. Yeah.
It tells you on 6 LEDs, it's suffer.
Okay. I haven't seen it. I'm okay with that. So I haven't seen those. Yes, right? We just know that if you measure the homes on each leg, and they all measure about the same, and you and the ohms of the compressor. So you would pull the plug off of it, right, and on each sled, each pin, right? So UV, WW, right? And as long as they own all the same, you're gonna be looking around 1.6, depending on which compressor it is, which model we have. Right? Yeah, well, mostly, but there's some, like, I think one of our compressors operates at a higher range. But so as long as you check it in there within range, then the compressor probably is the problem unless it's locked up. That's the only other thing. So it's either going to be the board or the compressor, or it could be the cable, the wires going from the board to the compressor. Make sure they all come out properly as well. The only time I've seen where the compressor at the start and is throwing that code, most of the time the compressor is locked up. I've seen most of the time it's locked up. I've very rarely seen the board bad. I have seen it, but it's not often that I see the board as the problem. It's typically going to be the compressor. Talk about that cable that goes between the drive board and the VSODU. This is that cable I'm talking about. So up around, right back in. So you can see the cable plugs in here. It plugs in right here on the board. So if you get that right, you get a ball on that line, and that cable most of the time is going to be the problem. Make sure it's opening out properly, and make sure that it's connected properly, right? So if not, then it's either going to be the drive board or the VSOP problem. All right, so any questions on that, on the outdoor unit?
Para los que no escucharon, no. Estaba hablando de la EBC o básicamente llega a dañar componentes de una pequeña memoria, de tal manera que se llega a dañar esa tarjeta y tomamos esa pequeña memoria a la tarjeta vieja y ponerse la tarjeta. ¿Okay? También algo de lo que estuvo mencionando es básicamente cuando cambiamos la tarjeta el compresor, primero revisemos de manera desconectada la resistencia, porque el cargador de 6 ohms. Y si en este caso tenemos la resistencia y no está aterrizado el compresor, bueno, prácticamente lo más probable es que no sea falla de compresor, sea falla de la tarjeta. ¿Okay? De igual manera, puede haber unas ocasiones en que se esté dando ahora sí que esta resistencia, pero el compresor puede estar bloqueado porque tenga ahora sí que la base del compresor. Algo que podemos hacer para poderlo intentar arrancar, una de las ocasiones es o retirar a la refrigerante. Camilo, aquí tenemos el número de partes de las tarjetas. Ya viene con programa. Y de
We'll have the breakdown for parts. It'll tell you what model that part is. So you can order that as a separate part. That else, you can replace it.
The new have updates or is the same for all models?
The version of software, version of software does change, but it will come out in in the newer boards or so when we go to the M1 product, is that what we're referring to? That's going to change because it's going to have different nuances that
The inverter also.
yeah, right.
Right.
Right, so it's not going to be even the same compressor or it's going to be the same inverter drive. So that's all changed. That's what I was trying to talk with Gail, and that's why I want you guys to come to our training here. There's a lot of changes that are coming. And we can't speak to it now because we haven't put that training out. So as soon as that training comes out, I've invited you to come to that training so that you can come back. Okay.
So we need to use the same version.
Yeah. Right. Yeah. So right now it's the same version. Right. So I mean, you can look and see what is it on the board, drive boards right now. I don't even know what version it is right now. Drive boards. Well, it's not a drive, it's on the VSO. Is it? Yeah. I didn't know if it changed. I know they're talking about. I think that's it. Though. We're not changing.
Well, the new one, that software version, but it'll be a different board. So
Right. That's what I'm saying. But
sin embargo, por ejemplo, en la lista de explotado o explotado de partes, muchas veces nosotros encontramos que dice para versión 19, esa versión no eso tiene lo que es la serie del equipo. Entonces la fecha de fabricación, ahora sí que la semana de fabricación y la de fabricación. Y con eso nosotros podemos detectar la versión correcta que llevaría ese equipo para poder suministrar en tal caso la memoria que necesitará. ¿Okay? Pero es muy importante tener la serie del equipo para poder saber la versión correcta de la tarjeta.
so, and course, installation practice. About if you don't use it. So if Wi-Fi is the issue, don't connect it to Wi-Fi. It doesn't have to be connected to Wi-Fi to work. Okay. So the air handling installations need RHMB, RMBA, RHMB, so air flow sources. Dual fuel gas furnaces, the air flow set furnace lockout. So the only thing we're concerned about today is the RHMB. The charge requirements and recommendations. When you're charging the system, you want the drive volt, outward drive volt to be at least greater than 55 or 55 or better, right? Indoor drive volt should be more than 70, but less than 80, okay? Should be between 70 and 80.
55 grados más o menos son 13 grados centígrados. Aquí es básicamente cuando carguemos aire refrigerante, que garanticemos que la temperatura ambiente esté arriba de los 13 grados y lo que es la temperatura interior esté alrededor entre los 20 grados y los 28 grados. Okay.
So before you start to charge the system, must let it run for 30 minutes. Okay? This lets everything settle out. It gives the EEVs time to get the right positions. Once you start doing that, you're going to start monitoring subcooler. You want to check your wet bulb delta T across your evaporator flow. Charging between 70 and 80 degrees indoor temperature. Charging recommended between 74 and 80 indoor temperature. Most matches the evaporator feed. So that's why you want to do that. On-demand dehumidification must be turned off at the Ethernet. It can't be turned on when you're doing that. Also, on the 20 series, we have an airflow trim, which we'll talk about what that is in just a little bit. That needs to be set to 0 also. So make sure that's not on. Okay? So, fine-tuning the refrigerator charge, starting with, well, we don't talk about this, we're past 48 in the control center. We're now operating on Ethernet near version 56, not version 48. So that's kind of changed. But the steps we're putting it into this test mode. We're putting the system into heater cool, whichever mode you want to charge in. And then give it a call for which by turning the Ethernet up or down. So the best way to do it is show you this row. Okay. So on the Ethernet, you're going to click the hamburger, right? The Big Mac, right? Big Mac, right? So once you do that, you're going to hit service. Be in this corner, not getting along. That's okay. Don't breathe. Okay, so. So you click service, okay? Oh, wait a minute, it went backwards. There we go. Click service. Then you're going to come here. You'll see outdoor unit checkout. Okay? You get the outdoor unit checkout. You get the outdoor unit checkout. And then you're going to toggle this where you want cool charge or heat charge. Once you do that, you get it to say you want cool charge, you're going to hit start test. What that's going to do is that's going to ramp the system up to full speed. You're going to let that run for 30 minutes at full speed. Okay? Once you've done that, then you're going to have your gauges on. You're going to check your subcooling reading. And then you're going to go to your charging chart. Right? So this charging chart is very simple. You look at what temperature you are outside. Whatever your temperature is, wherever you fall in here, let's just use 95 degrees for outdoor air temp. And you're going to use that's RQ17. Let's jump to RQ23. So it'll be for 20 also. Based on high pressure over low pressure. It should be. As long as you get your substance right around that, it should be very good. Right? Full charge, ready to go.
Okay. Bueno, básicamente lo que hemos visto es que alargar lo que es una refrigerante desde Iconet, donde vamos a empezar primeramente en las 3 barritas del lado izquierdo para entrar a este menú, donde vamos a partir que es completamente todo, podemos entrar a la parte de servicio y vamos a encontrar lo que es el modo ya sea de calentamiento, de carga en modo enfriamiento o carga en modo calefacción. ¿Okay? Lo activamos, el sistema lo que va es empezar al 100% durante media hora. Una vez pasada esa media hora, porque ya el equipo ya que tenemos opinión de trabajar el equipo, lo siguiente es que vamos a tener una pequeña tabla la cual nos puede decir el equipo. Ok, esta tabla. Ok, en esta tabla es muy fácil usar. Básicamente vamos a tener del lado izquierdo la temperatura ambiente en la que está trabajando el equipo. Obviamente
grados Fahrenheit, pero bueno, tenemos que hacer la conversión y de acuerdo al modelo de la unidad, pues vamos a tener tanto esta presión de descarga como la presión de succión. En la parte de abajo, lo que estamos encontrando es, igual, dependiendo de la temperatura en la que estamos, la temperatura de enfriamiento que deberíamos de tener. ¿Okay? Entonces, ya que trabajamos al 100% con los datos de presión y los datos de enfriamiento, con eso es por lo que sale la temperatura en este tipo de sistema. ¿Okay? So, if you're charging a heat, right? Do the same thing. What's your outdoor drive volt, right? Based on that, your unit, if you what your pressure should be, where your substance. Okay? Pretty simple. Esta tabla es para el modo calefacción, la anterior era modo enfriamiento, esta es calefacción. ¿Okay? En vez de subenfriamiento, lo que vamos a ver abajo es sobrecalentamiento. So we'll talk about some sequence of operation. So when the compressor starts up, the first 2 seconds is going to ramp up to 1200 CF, 1200 RPMs. Right? And it'll stay at 1200 RPMs for 3 to 7 seconds, then it's going to ramp up to 1500 RPM. It's going to hold that 1500 for 8 to 17 seconds. After 18 seconds, that's when it will start its variable speed operation. Okay, so that's when it starts to modulate. So it's got to take that time to figure out the position and also have all the communications going back to the VSOU, to the boards, to Internet, all of that will come together to determine what position the compressor is. Control logic, so you get a 3-speed operation for 70 speed is determined by, well, this is called legacy. On the RP17s, 3-speed operation, intermediate, maximum speed determined by thermostat call, Y1 minimum. Y1 plus 15 minutes, we're going to intermediate to stage 2, and Y1 and Y2 will go to maximum 13. So, if you are checking for any faults, we've got a 7-segmented display that is on the VSOU that will give you a fault code, right? If there are fault the SSD will show you those fault codes. Turn it on and you see a 0, not a fault code. So there's no call for heat, right? There's no call. So the way it works is if there's no fault, it's going to attempt communication with the heat connect and with the indoor unit. So attempts communication first. If for some reason you place a stat on there, after that it will go to the legacy mode. And communication has priority. So we set this up to where we want you to use Ethernet. You have to use Ethernet. That the legacy stats are only for purpose. Okay. So when we're calling for cooling, all right, we'll either have a little C or a big C or a little H or a big H. Little C means first stage or low speed. Big C means high speed. Okay. So the compressor has the ability to increase, we have the ability to increase compressor speed based on output. Action speeds vary by model operation mode. So how we measure that is in RPMs. Most compressors will operate around 3,600 RPMs, like most normal compressors. These compressors can go up to, depending on if you're in overdrive, up to 1,000 RPMs. And down lower than that, right? Down to somewhere in between. So cooling load above 100, 26 loads below 32. I lost my call. Anyway, so we can carry that speed. One thing I want you to know about the actual speed we hear by model is 7,000 RPM. These systems don't sound right like normal systems. These compressors, when they're at 7,000 RPM, can have a high-pitched whining sound, and that's normal operation. So if that happens, you don't have a problem. You need to see what RPM you're operating at. You can see that on the Econet thermostat. They tell you what RPM this compressor is. Okay, so you can look at that. And if you're in overdrive, let's say for some reason where I'm from, and definitely where David's from, it can get above 100 and stay above 100. Well, on those days, if it's 105 side, then that compressor could be an overdrive. If it's an overdrive, it's going to be screaming. It's going to make that loud, whining pitch noise. And so that may make your customers think that there's something wrong with the unit, and there's not. So that's the reason I kind of mentioned this. If you hear that high pitch whine, verify the RPM before you begin the compressor. Okay. All the inverter heat pumps utilize the man defrost system. This is man defrost concept, right? Is basically if it meets a certain criteria on outdoor air temperature oil, there's a set point there. If it meets that set point, then it will initiate the cycle. Then that defrost cycle will ramp down. It will actually slow the compressor down, and it goes into what we call a reversing valve shifting mode, so that you're not hearing that noise that it makes. So after the 30-second delay, the reversing valve is going to shift, and the outdoor is fully open bypass. Just remember, okay? So the outdoor will be in bypass mode to allow the outdoor fan shuts off, and the compressor will ramp that max heating speed or max heating speed. Once it does that, then it's going to the outdoor termination sequence is going to start at 60 degrees of temperature versus 70 standard heat pumps. So we're looking for 60 degrees on the coil. Once we hit 60 degrees, we're going to start our termination sequence. Once that happens, that compressor is going to ramp back down to this reversing valve shifting speed. It's going to give you a 30-minute time delay. Once it does that, the reversing valve shifts back into heating mode. Then we're going to go to the outdoor heating, it's going to return to its previous position. And it's going to start normal heating mode operations. Okay. Something else that it does before that happens is it will go into what we do a oil return sequence, which lasts about 6 minutes. Okay. So it may stay in that defrost another 6 minutes in order to make sure all the oil got returned back to the compressor. Okay. So that's that way you know if it terminates, if it's longer than 60 degrees or it's more than 60 degrees, it could be doing an oil return. All right, the heat ends during a defrost. So this is on, if you're on a regular Ethernet thermostat, let's say that you have your temperature in the home set for a certain temperature, and that satisfies while you're in a defrost mode. You have the Ethernet thermostat, the outdoor unit is going, the system is going to complete its defrost mode. Right, it'll complete the entire defrost mode all the way with, including the oil return process before it shuts off. If you're in legacy mode, it'll shut the system down, but when the system calls for heat again, it starts up, it will go back into defrost mode and complete the cycle, including 6-minute oil return. Okay, so if it doesn't stop, it just picks back up where it left off. Does that make sense?
O sea, básicamente ahorita está hablando tanto del proceso de arranque, la postura anterior, y del modo de deshielo del equipo. Ok, o sea, aquí pues al final casi no tenemos deshielo, la duración del deshielo viene siendo 6 minutos aproximadamente, y en el modo de arranque, bueno, básicamente igual tiene una pequeña rampa de valga la redundancia, de arranque el sistema, donde realmente, ahora sí que durante algunos segundos entra a 2000 revoluciones el compresor, posteriormente se va a ir a su máxima capacidad durante 15 minutos y ya a partir de ahí va a empezar a regular de acuerdo a las lecturas que tiene. Estos compresores que tienen estos equipos son diferentes a los compresores tradicionales. Un compresor tradicional mencionaba que anda alrededor de las 1200 revoluciones por minuto, mientras que estos equipos pueden alcanzar, o estos compresores pueden alcanzar hasta las 7000 revoluciones. ¿Okay? Entonces, igual si hay algún ruido que al cliente le parezca normal, pues sería primero bueno revisar lo que es el control, el icono, porque el mismo icono nos puede dar lo que es o podemos ingresar a un menú donde nos dice la frecuencia o la velocidad del compresor. ¿Okay? Entonces, obviamente, si está elevada la velocidad, en este sentido también podría ser un poquito más de ruido que un compresor normal. Entonces, es básicamente. Sí, o sea, ese es el máximo que puede llegar a tener el compresor, obviamente, para a lo mejor alcanzar una temperatura más rápido, pero efectivamente el icono tiene su propio sensor de temperatura y en cuanto detecta lo que es, ahora sí que llega al set point, va a ir bajando. Aquí también hay que tomar en cuenta que, bueno, anteriormente mencionaba que tenemos un sensor de temperatura en la descarga del compresor. Ese sensor que se activa más o menos a los 105 grados, está también para proteger que se me pueda sobrecalentar. En ese sentido, cuando llega o si el equipo llega a censar esa temperatura, lo que hace es detener la velocidad del compresor para evitar que se siga sobrecalentando. La mantiene. Si baja la temperatura alrededor por debajo de los 100 grados, de los 90 grados, en ese momento quita esa protección. ¿Ok? Y, mira, que esté ciclando es una operación anormal de los equipos inverter. O sea, lo que trata el equipo siempre de hacer es mantener, en el momento en el que vea que empieza a disminuir la velocidad, el mismo compresor va a tratar de irse o tener la misma secuencia que la temperatura interior. Va a empezar a bajar la capacidad para que pueda mantener nada más. Esa es al final es la función del inverter. Cuando te llega por temperaturas muy abajo, quiere decir que pues, tu equipo está sobredimensionado, que ni aunque sea la mínima capacidad, que te gustará 10, que sean 10 Hz o algo así, el 10% del equipo normalmente, te sigue enfriando. Entonces, si aún con eso ya llega a 2 grados por abajo, es cuando se apaga todo, normalmente, pero es porque tienes un equipo sobredimensionado. ¿Ve?
We've already talked about some of this on your suction transducers and also on high pressure switches. So the different operating parameters in cooling mode will open at 50 and close at 95. Okay. And then on your heating modes, it opens at 15 and closes at 40. Okay. So the difference in cooling there. Connected directly to the inverter or high pressure switch automatic resets to 610 PSI. Resets to 49. So it opens at 610. Consider during a call for press operation. So, pressure operation stop when you have a lower high pressure switch trip. Pressure operation stop, your EPD will close. The outdoor fan will stay on for pressure switch. So for a low pressure switch, code 21. It's open, we code 29, right? So low pressure is a code 21, high pressure switch open. System inverter, 5-minute cycle delay. In fact, the 5-minute delay, low pressure switch. Operation after 5-minute delay, when the switch is open. Cycles 3 times on one of these pressures to be blocked out for 4 hours. Okay, so The only way to stop that lockout is to power down both systems, indoor and outdoor. Power back on outdoor first, and power on indoor second. Okay. Over temperature protection. So remember we talked about the discharge line got above 225 degrees for 30 seconds. We'll give you the fault code. So we'll show up as a fault code 17. Compressor RPM is reduced for until it gets to 200 degrees Fahrenheit. Once it goes below that, it'll ramp back up to the command speed. If it doesn't, then we'll shut the system down at fault code. On your line voltage, your inverter drive monitors your line voltage. So if the line voltage is below 179 volts AC, the unit will not start. Okay, so if line voltage is below 170 volts AC during operation for 4 seconds, the unit will shut down. Once the line voltage hits above 187 volts, 4 seconds, 3 minute time. Any questions on that?
Una pregunta. ¿Sí entendieron más o menos la protección de temperatura que les había comentado? Bueno, aquí básicamente es de voltaje. ¿Sí?
So overcurrent on the maximum your high discharge pressure, high compression ratio, cricket cycle pressure. That's what's going to cause the overcurrent protection. So when that happens, the compressor speed will decrease. Now, what can cause high discharge pressure? Overcharge. Dirty condenser coil, right? Fan motor not operating properly. Okay. How many of you guys know how to check the compression ratio of the compressor? Stop raising your hand, David. Nobody? You ever heard of checking the compression ratio of a compressor?
Just checking low, high, fluctuating discharge.
Add 14.7. And then subtract, dividing the low into the high. That gives you your compression ratio.
Low divided into
High. So let's say you have 125 low and 336 high, and you add 14.7 to each. Take the high and divide the low into the high, and that will give you what the compression ratio. Okay, so see if it shows you. Sorry. I like this. Makes sense. So you should be somewhere between 2.5 and 3.0 compression ratio. Okay? Does that make sense on the side there? Low pressure plus 14.7, which is atmospheric pressure, right? Absolute. High pressure plus 14.7. Divide high pressure by low pressure will give you the compression ratio. Okay.
should be around what range?
2.5 to 3.0 roughly. Okay.
Y básicamente nos está mencionando que para sacar la relación de compresión del compresor, porque ya que lo dice es que no comprime, ¿no? Y para saber si está bien o está mal, debería ser alrededor entre 2.5 y 3 esa relación. Si está dentro de eso, el compresor sí me funciona. Y para calcularlo, básicamente es determinar lo que es la baja presión más el 14.7, que viene siendo básicamente una conversión para convertirlo en otra escala de presiones, ¿no? Que se llama absoluta. Entonces, por eso es el 14.7. Medimos igual la alta presión más los 14.7 y dividimos la alta presión entre la baja presión. Y eso debe ser entre 2.4 y 3 más o menos. Está adentro, pues el compresor funciona.
Compressor stator heat. So on these units, we don't use crankcase heaters. We use what we call stator heat. Prevents liquid refrigerant from settling in the crankcase. Liquid refrigerant can have an adverse impact on compressors, as you know. So how it works is we energize one compressor winder, which will generate watts of heat, which keeps that compressor warm enough to keep it cool. So we make sure that it sees a certain temperature outside, it will initiate that and bring it on. If it's 95 degrees outside, we don't need to operate that one. Yes.
What did the power before the start of? Okay, to how
Oh,
Start for
it's
free.
outside? I wouldn't use that on 50. Well, he's talking about initial power. So like he said, the initial power up is 12 hours.
okay.
Like, so before you're ready to do it, power up for 12 hours.
Okay, 12 horas.
So if the outdoor air is below 40 degrees, right, and the sun temperature is below 45, pressure's not running, right? So that's when you will have the heat operation out. Winding the energizer at the sun temperature is above 50 degrees, okay? Crankcase heater operating compression operation is allowed. That's it. Compressor blocking. David, I haven't taught this in a while. I don't remember what that's about. Compressor blocking. You remember that?
It's just saying that it's got a constantly listening to hold the compressor on so that below the
So it gets above that, yes. So it's just blocking unless those parameters.
logic is just
Yeah. Right. So there's logic built into the board that will not allow the compressor to go on unless it's parameters in there. It keeps the compressor from running unless it's parameters. Okay.
Tiene un algoritmo en la tarjeta que arranca el computador a menos que se parámetros. La temperatura que se.
Por los que no escucharon, básicamente lo que necesito es que tiene un algoritmo la tarjeta que se evita que arranque el compresor o lo va a bloquear, pero descubra el siguiente parámetro. Que la temperatura del ambiente sea mayor a 40 grados. Esto me siete, como 6, 5 grados, como 5 grados más o menos. Bueno, si es menor, no va a arrancar, lo va a bloquear. Lo dije al revés. Okay. Igual, ahora sí que el fondo, igual que tenga esa temperatura, si no se cumple, el compresor no arranca, ¿no? Entonces, para que hierve el refrigerante y también arranque con líquidos el sistema.
So on general diagnostics of this system, the first thing to remember is we call it the KISS principle, K-I-S-S. Keep it simple, stupid. Right? That's what we call it. Don't jump to conclusions. Follow your systematic troubleshooting. Most important thing you can do. If you don't follow systematic troubleshooting, what does that mean? Systematic troubleshooting. It means you go from A to B, B to C, C to D, E to C to F. You don't go from A to R to Z to Q to back to G over to B. Keep it simple. follow the path, right? Don't make it harder than it actually is. New system evaluations. We have on all of our equipment, we have something called a JSIS sheet, job site information sheet, right? That lets you write down all the parameters, everything that you need to know on this system, to tell if it's operating properly or not. So some of the questions you want to ask yourself, obviously, is it a new install? If it's a new install and the system's not operating, what could be some key factors that cause that? Could it be something within the installation? Could it be something that they didn't charge the unit right? Or did they not install something right? Is there airflow that's poor? Things to ask yourself. On the Ethernet Control Center, you can see all the different diagnostics there. You can go into the Ethernet service menu, and then you can look at your alarms, look at your alarm history, and that'll tell you what type of alarms that the system's been throwing. You're having issues with. They'll record the history of that. And you can look at those. This thing. Okay. So also your status screens. If you pull up status screens on the Ethernet, you can look at your AC or status, air handler status, right? You can take screenshots of the Ethernet with all history. We have separate communication faults in the registry. So you'll see different types of faults. So, Ethernet Control Center, you go to the service menu. Okay, once you go to the service menu, you find current alarms. Current alarms. You can click on history, right? You have the alerts. You can do a furnace checkout, the outdoor unit checkout if you have a furnace, which you probably don't have here. So you can also do a status screen. On these status screens, this is what will come up first. You can see what you've got. It's a variable speed 2-ton. Tells you what your outside air temperature is. Tells you what your cold temperature is. Tells you how it's an operating, if you turn this on or not. You don't have to turn this on, so it don't look tell you or will tell you, depending on if you energize it or if you select it. Then you can look at here and it'll show you what the inverter current speed is, how many RPMs your compressor turning, what your EV current position is, what your superheat is, what your full temperature is, your suction line temperature, suction pressure, liquid line temperature, liquid line pressure. So it tells you all the things you need to know that's going on with the system right from the Ethernet. Now I challenge you not to just use this information. Actually get your gauges out, put it on the system, and verify that the information that you're getting is correct. Take a subcooling reading, take a superheat reading, take amperage readings, take voltage readings. Make sure that everything that's supposed to happen is happening right. Okay. So Ethernet can help you troubleshoot, but that information you always want to double check and make sure it's correct. So on the Ethernet, it's on this RS-45 serial bus. Right, you're using 2 data wires, E1, E2, and they come in a ground, C, right? All devices have a green column LED that should be blinking rapidly. So when you're troubleshooting these devices, all devices disconnected, but power applied to the control. So what that means is you will unplug E1, E2, but you'll leave 24 volts connected to each board and the Ethernet, okay? You start reading that on E1 and E2, you should be about 3 volts DC. E1 to C should be about 3 volts DC. E2 to C should be 0.2 volts DC. Okay, so if those are all putting out those voltages, then the chances are it's not your board, right? It's going to be your wiring. So think about that. I've had situations when I worked for a different manufacturer that I got a phone call and the gentleman told me that it wasn't communicating, and I asked him to check his wiring. He told me he checked his wiring. We stayed on the phone for 2 hours to try to fix his problem. He was having with not communicating. He checked all the voltages on the board and everything checked out okay. And I asked him again, have you checked your wiring? Of course, I've checked my wiring. Everything's fine. Next day, I drove 2 hours to his location. And I had the homeowner yelling in my face, right? Screaming at me. So I get downstairs to the basement where all the wires come together. The third wire that I grabbed the wire nut and pulled the wire right out, right? They weren't connected. Rewired everything back up. I was there about a total of 8 minutes. Wired it back up, went upstairs, turned the system back on, everything communicated, and everything operated fine. I yelled at him after the homeowner yelled at me, right? Always check your wiring. A lot of times you'll find that the wire is broke or it's loose, right? Make sure your connections are proper before you get them aboard. Okay? So on your indoor device, like I said, you're going to leave R and C connected. Go check E1 and E2. So you'll know if it's defective, right? If the board's defective, because on E1 and E2 you should have 3 to 3.5 volts DC. That's good, right? E1, E2, 0 volts DC. If you have E1, E2 and you've got no voltages, then you have open E1 and or E2. You got a broken wire or bad connection. Same thing. So like I was telling you, check the board. Check each board the same way. Remove the E1, E2, be power connected. And if you don't have anything there, then you've got something else going on. If the board checks out okay, and you power it up, and you check and you put the E1, E2 wires back on the board, and you've got voltage going out, but no voltage returning, then that tells you there's a problem with the wire, correct? If all voltages check, if all boards check out okay, right? So don't be so quick to get the board. This is the show the board is saying. So this is on outboard devices, the same thing, right? So on some diagnostics, these are some of the codes that you might see. Inverter outboard unit software change, ESODU, right? So version AC 01000141. I think Dave, you said we're on 68 on the outboard on ESODU right now. We're on 68. So this has changed. So this is not, our version isn't 41 anymore. Our version is 68. So a 928_O, this O, that underscore O, that O tells you it's an outdoor unit problem. Okay? So it's now 928_O lockout, right? That's the lockout code. The H8929_O inverter fault communication failure. Remember the wire that I told you that goes from the ESODU up to the drive board? That's the code you'll see is a 929_O, and the first thing you want to check is that wire to make sure it's connected good, make sure the pins are okay, and make sure it ohms out from pin to pin on the wire itself. So you make sure the wire is good before you. It's I'll have to pull it back up and show you, but it's the wire that goes communication wire that runs from the BSODU all the way up and it ties into the drive board. It's that one wire that goes up. I'll show you on this up here, okay? I'll point it out. 2-core wire? I think it's 4. 3 or 4. It's 4-pin plug, so it's either 3 or 4 wires. To reduce nuisance low pressure trips, change the compressor cycle time from 4 to 5 minutes. Now syncs with the indoor EXP. Opened after a cycle turns off. So added 90-second delay on the for this, we added a 90-second delay for low refrigerant pressure changes done on normal cooling mode. That way, if it's a little cooler and our pressures drop before they come back up, there's a 90-second delay before we'll kick off the pressure. Okay. So we've also changed the overdrive operation. The outdoor and indoor fan speed remains at high. It could be reduced in overdrive, but now we keep that at high. So that's something else we changed. So when we go into that overdrive, I was talking that it could be at 7,000 RPM. Our fan should still be at the high speed on those situations. Okay. We don't have those software. So these LEDs right here will also blink when there's a text code. So you've got a text that is yellow, right? Drive is under protection. The yellow LED blinks how many every time it stores a code. You got a hardware fault. It's a red LED. That drive is under a fault depth. The red LED will blink several times. You got there's another LED as well. It's I think it's green. So we've also got these two buttons, S and SW2. Okay, so those two buttons, if you press them right, you can look at function as set, so you can see what the functions are. You can look at the status, you can look at the diagnostic code, or you can do testing. So they have 4 functions. So the menu structure, FC, when you press the buttons, FC is going to be the first one that'll be your fault codes. So once that pops up, you'll select it, and it'll tell you what your fault codes are. The second one's going to be what your super is on the outdoor unit. The CS will be your compressor speed, DF will be defrost, so you can put the system in defrost. So if you want to do that, you will press test and SW2 simultaneously for 5 to 8 seconds. You'll go into that function. Right, and then you can go into active faults once you get there, and it'll tell you what your active faults are. Okay, that is also communicated to the control center. So that fault that's on the outdoor unit, it gives you a better explanation. If you go to the Ethernet, you can see what the fault is, and it'll tell you what it actually is. And then you can look that fault up in the manual. It'll tell you how to troubleshoot that fault. Okay. Then, so on the time delay bypass, those are your flashing big C, little c, big H, and little h. If you want to bypass that time delay, you press the test button, and it will bypass that time delay. Okay? I don't recommend you keep doing that, right? If it fails and then you get time delay, you reset it. If it fails, get time delay, you reset it. Don't do that. If it fails the second time, stop and figure out why it failed. You can also do a forced compressor start. Press the test button for 5 seconds. It'll force the compressor to start if it can start. If the compressor can't start, it won't start at all, right? But if you want the force the compressor to start, you can hold that down for 5 seconds and it'll force the compressor to start.
Depress.
Say it again?
Depress.
Yeah, same thing. Press. We say press. So you say depress, like you compress or depress. Yeah. Same thing. So press. Hold for 5 seconds. Okay. So you can do a forced defrost, right? So you're going to press the test button. You go into forced defrost, you have your heat. Okay. So when you want to go, the thing you have to know is when you want to go, if you want to test defrost, see if defrost works when you're doing a new installation, put in the defrost mode from here, but you need to make sure that this outside air temperature is above 50 degrees. Or below 50 degrees, I'm sorry, not above, below 50 degrees. If it's not below 50 degrees, it won't go into defrost, okay? So it has to be there. When you press the test button, defrost will terminate normally. So once you put it into defrost, it's got to see the 60 degrees before it will initiate that, and it will also do the 6-minute oil return segment too, right? It'll go through an entire defrost segment. Okay. So Inverter service diagnostics, you can disconnect the PWM connector. By 24 volts to the motor leads, the motor should operate full speed. So what this is saying, if you want to test that ECM motor, right? You can unplug it. You can wire 24 volts straight to the motor. If the motor's good, it should run. If the motor doesn't run, change the motor of the module. If it does not run, or if it does run, then you need to change the board or the cable going to it. Verify the cable is not open. So read both ends of the cable to make sure that they read normal, okay? Before you change the board. Inverter service diagnostics, so inverter testing. Issues communicated to the outdoor control and Ethernet system. If we have an inverter problem, it's not, if you notice that there is a defective board, there's no way to fix that in the field, you replace it. That's all you can do for it. But again, remember, power in, power out. If everything checks good on that board, from start to finish, from 220 volts coming in to DC voltage going out, then the board is not the problem. Okay? So, but if there is a problem with the board, all you can do is replace it. On the filter board, power in, power out. If you have the same power going out that you have that's going in, there's nothing wrong with that board. Okay? And to this date, I've never seen a filter board go bad. I haven't seen one at all. You seen one go bad, David? No. So then you've got the inverter service diagnostics here, the inverter fault conditions. You got several possibilities with an inverter fault. Some of the main possibilities is inverter over temperature, inverter fallback, or voltage issues. So if you have improper voltage coming in, too low voltage, too high voltage, that will cause issues. Inverter fallback, you've got the temperatures that are too high on the discharge line, and it's going to create that coming back, right? Another thing that could be happening is inverter over temperature. On the back of it is a heat sink on the back of the board. If that heat sink is dirty, or if it's got something on it, if there's something wrong with that, that could cause that board to overheat. If the fan is not operating at the right speed, you may not be moving enough air across that board to cool it down. That can cause the inverter over temperature. So there are several things that can cause that problem. Okay. The inverter drive becoming excessively hot, like I said, it's called back and shut down to protect that drive. Also, the inverter fallback suppresses speed reduction to return tolerances. Remember the discharge line, like I said, above 225. Resetting this drive, guys. A lot of people don't, they're told to reset the drive, but there's nowhere in the manual that talks about how to reset the drive. Basically, you shut power down to the outdoor unit for 5 minutes. And you let all of the capacitors deplete, and then after 5 minutes, you power it back up, and that will reset the drive. Okay. This is the heat sink right here. Like I said, inadequate airflow. You got a dirtier block of oil that's not going to let you move much air, so it's called that heat sink overheat. Dirty heat sink. If it's got junk built up all over, because the coal can get dirty, we'll soak in that heat sink. If you're going to clean that heat sink, don't take water and spray the heat sink. Take a wire brush, just brush over it lightly to get anything off of it. You don't want to use direct water spray on that because, yes, there's a seal between it and the inside compartment, but seals fail. And if you spray water right into that unit, you've had a bad day. That's a lot of money. Okay? And also, the refrigerator being undercharged or overcharged can cause the same issues too. Okay?
Between the heatsink and the PCB, do you guys use thermal grease?
Not between the inside. Talking about where we just use a foam. I think it's just a foam. I don't think it's
Making contact.
Like a mini split, yeah, it's not serviceable. Like it's not serviceable. You're talking about the grease.
No, but between the heatsink, it's right here, right?
Yeah.
And what it's doing is taking away the heat from the PCB.
Right.
When they touch that surface, they usually.
Oh, they probably do. Yeah, it's not.
Grease.
Yeah, they probably do.
Sometimes it wears off.
It does, but I don't know that we have a kit to put.
We don't sell it.
We don't sell it now. We don't sell it. But I know there's manufacturers that do. They sell where you can actually put the grease back on
Just like the toothpaste, they sell it.
Yeah. So I don't know that we recommend putting on their apps. I don't see what you're bumping. I don't think it's service. Yeah. So I don't have. But I've seen what people have done, and I've never like everybody I've ever worked for, as far as we're manufacturers, we've never supplied that. But yeah, you know, in stores, electronic stores. Right, so like a regular electrical supply house, you could go for us, it has to be electronics. A929_0 is communication fault. So go back to what you're talking about. It's this wire right here. So this wire right here. So this wire up and over, it comes right back down and ties it right here on this PSO. So that's the one we're talking about, the A929_0. It is a communication fault. So what that means is this board is not communicating to this board. And that's the communication cable for that. So if that cable goes bad, you'll get this fault. If the PSODD or the inverter board are bad, you'll also get this fault also. The main thing we see is this cable. So check the wiring on the cable. Verify that it ohms out fine, right? That you have conductivity through it. Check the pins, make sure they're not broken or moved, right? And also check the pins on the boards to make sure all the receivers, the receptacles on the board, that they're able to receive the pins, right? So we've seen those problems also. Okay. This right here is I'm going to come to you because I can't hear you. I don't know if we've ever read it. But yeah, but if you're doing maintenance, annual maintenance or a city annual maintenance, not a bad idea. Follow and make sure you're okay. They're not doing. I'll see you every 6 months or something. You're not, especially if you're in a high explosive environment. I see that why that would be a problem. Right? So I would do it for every 6 months, every year.
Siempre esto preguntó que con qué frecuencia deberíamos dedicar las eléctricas. La respuesta es que con cada mantenimiento, ¿no? Ya sea arráncalo, por lo menos cada 6 meses en el procedimiento de mantenimiento se podría dedicar. Esa yo te la recomendaría cada vez que cambia la tarjeta. Si tú la tienes pegada y no te vaya la tarjeta, no te cambiar. Ya si cambias, muchas veces te llevas parte de la pasta. Pero digo, según no están seguros de que venga, vamos a revisar a ver. Yo sí traigo. Lo revisamos ahorita.
Yeah, I was getting. Man, I'm ex-military. That's bothering me. Sorry, Mom. I don't like fireworks. I don't like going to fireworks shows. I'm ex-military. That really irritates me. Sorry, I apologize. So on these, this is your model data card. The question was asked earlier that can you get another one if this one goes bad? Absolutely, yes, you can. These are the codes that you'll see if you see that 8925_0 or 951_0 or 952_0. Those are the ones you'll see to let you know that your memory card is issued missing or corrupt. Right, so if it's corrupt or missing, then yes, you will have to replace it, and there is a part number for that. What David was talking about earlier is we have, everybody knows that we have a new product coming out for M1, which is the DOE's energy proposals that have made us change how we test our equipment. So we changed the testing procedures. So Reed has built all new equipment for this procedure or for this transition. And it's going to be happening for us in January of 2023. Okay, so in those units coming, you will no longer have model data cards, and you will no longer have dip switches. All dip switches will be gone. Okay, you'll have to have the contractor app on your phone, and you'll have to connect via Bluetooth to be able to set the system up. Or if you use the Econet thermostat on those new systems coming, you don't have to do anything. It'll set it up for you. Okay, but always use the Econet thermostat on our on 20 SEER equipment. Also, the designation of this equipment coming is going to be different. There will no longer be a 20 SEER. It'll be an 18 SEER 2 or a 16 SEER 2, right? So we're changing how that's viewed, but it's still the 18 SEER 2 is still just as efficient as the 20 SEER 2, the 20 SEER 1, right? So, but there's a lot better performance that's going to come out of it. They're going to be a lot more reliable. They're going to be a lot easier to set up. If you happen to put a legacy thermostat on one of those communicating systems, then you'll still have to connect via Bluetooth, and in the app, you can set up how that system is set up. You can set the system up via the Bluetooth app, okay? But we're inviting Ricardo and Miguel to come to the US, to come to David and I's training class for that. It's going to be in early September.
September 7th and 8th.
Yep, September 7th and 8th. And Ricardo will come back and train all of you guys. You'll be experts, right? Ricardo, they'll be experts, right? Okay. Ricardo don't seem too sure. Oh, you'll be semi-experts, I guess, for Ricardo. So guys, that's it. That's the class. Any questions? Any concerns? Any boos? Any no's? Any get outs? No? No good. So you guys like jokes? Like jokes? Yeah. But do you like jokes? Can you translate my joke for me? Or will this translate it? We think we'll do okay? Okay, so here's my joke. St. Peter and the top officials in heaven were having a crowding issue where people that were coming to heaven were rushing the gate trying to get in. And it was causing a lot of problems. So they had a meeting. They determined that they were going to combat this issue by only allowing people to be in single file lines. And as they approached, they had to tell them while they were there, how did they get there? So the day comes and they implement the plan. The first guy comes up, he says, slow down, tell me your story. How did you get here? He says, well, I live on the 25th floor of this high-rise condominium. He said, this morning I got up to go to work, and I got to work, and I just had this feeling that my wife was cheating on me. So I go home at lunchtime, take the rest of the day off to catch her in the act. He said, when I got home and I opened the door, I could smell his cologne. I know he was there. He said, I got angry, furious, and I went around looking for him everywhere. I looked under the bed, I looked in the cupboards, I looked in the closets, I looked in the bathroom, I looked everywhere. Could not find him. He said, I got so mad that I went out on my balcony, cool off and calm down. There he was. He was hanging by the banister. So I ran in the house, I grabbed a hammer, I come out, I start hitting his hands with a hammer, and he falls. He lets go, he falls 25 stories. But he lands in these bushes, it doesn't kill him. I black out. And when I come to, I'm pushing the refrigerator over the banister. He said, finally, the refrigerator lands on him and kills him, but in the midst of that, I had a heart attack and I died. And St. Peter said, you had a really bad day. So the next guy comes up and he says, slow down, tell me your story. How did you get here? He said, well, I live on the 26th story of this high-rise condominium. And every day, I work out, take good care of myself. He said, I eat good. He said, I don't smoke, I don't drink, I go to church. He said, today I was working out on my balcony. I was stretching on the banister, trying to get ready for my workout, but the banister broke and I fell. He said, but luckily I caught the banister below me. I was trying to pick myself up with this maniac bells on my hands with a hammer, and I fall 25 stories. He said, when I hit the bushes, I swear the angels must have landed me. Because I looked up to give God thanks as we're and St. Peter says, you have a very bad one. So the next guy comes up and goes, slow down. Tell me how you got here. What's your story? He goes, okay, picture this. I'm naked in a refrigerator. So that's it. Well, look, I gave you 10 minutes back for your time. That's pretty good.
Typical superheat design range.
Superheat is going to vary on these, and you should see similar. I mean, it will vary anywhere between 6 and 16. It's going to vary based on it varies. Yeah. What's going on? Right? What's going on? So superheat will vary. Huh?
Fahrenheit.
Yes, Fair.
6 to 16.
Yeah, degrees Fahrenheit. It'll vary.
Subcooling.
It should be. It'll tell you on there, but it can vary depending on what unit. You'll have to look on the chart, but it's going to be anywhere 7. I've seen the size 17, maybe a size 45, 50. So it just depends on heating.
7 to 17.
Yeah, I've seen 6 to 17. Yep. I wouldn't worry about it. But it's all. So tell me what they're celebrating. What are they celebrating?
Someone said they're getting ready for Mexican Independence Day.
Okay, so that the Mexican Independence Day happened in 1942. That happened in 1942. September 1942 is when Mexican independence happened. You know how I know that? Don Julio, 1942. Actually, what 1921. 1921. There's a tequila in the South. It's called 1921. That's Mexican Independence Day. 1921. So I was wrong. I was thinking about it was 1921. 1921.
Well, I guess on the Independence Day was that year, but
Yeah.
it was 1821.
1821. Because they said 1921. I guess they told me wrong. They lied to me. It's 1821.
1821 is Mexican Independence.
I guess
Started 1810, finished 1821. About 20, 30 years.
Yeah. Weird. Okay. Well, I guess they lied to me. Because that's what they told me when I went to buy that, right? A tequila, a friend of mine turned
Maybe it was like 100
Maybe. That sounds right too, but they told me that when a friend of mine, actually what happened, I was in a Mexican restaurant back in Georgia, and we were talking in Georgia, all of a sudden, he likes my he said, so you like, he said, you just grab a shot glass, and he says, this is, I found this the other day, so this is really good. So, he says, that's what he Maybe.